became a science. Only a century ago, it became a scientific discipline and quickly accumulated the data on causes and mechanisms of aging and age-related pathology. However, successes in lifespan extension and rejuvenation were much more modest, if any. We learned how not to shorten lifespan due to rational lifestyle and progress in medicine, but not to extend lifespan beyond the limits set out by nature. Up to now, the so-called maximum lifespan of species-specific maximum lifespan remains the golden standard of longevity. There are a number of evolutionary well-shaped models to study, to understand driving forces and mechanisms of rejuvenation at the level of whole organism. I mean, primarily embryonic development, resetting, aging clock, etc. Even more we know about rejuvenation at the cellular level, primarily due to induced pluripotency and reprogramming. Suffices to mention that we can take a cell from elderly patient or a centenarian and convert it to a state similar to embryonic stem cell and redifferentiate back to the somatic cell of any type and age. Definitely, unlike the physical time, which is irreversible and flows unidirectionally only from past to future, biological time is reversible, and cells can be moved forth in the back from the time axis. The statement that lifespan extension and rejuvenation could be manipulated clearly follows from evolutionary experimentations, which resulted in the creation of 3 clusters of species. First cluster, this largest cluster, is so-called obligatory mortal species. These species usually are relatively short-lived, no more than 100 years. The second species is so-called quasi-immortal species, sponges, hydra, jellyfish, etc. By existing estimates, such species can be more than 1,000 years. And finally, there is an intermediary cluster of species which are basically mortal, but they live long enough to consider it as quasi-immortal in the practical sense. I mean, so-called extreme longevity, representatives of extreme longevity, for instance, ocean whales, which live more than 200 years, Greenland shark, 300, 400 years, Arctica Atlantica, more than 500 years, etc. The obvious difficulties in lifespan extension and rejuvenation make reasonable the question, why not to extend the frontier of research by using various models of combined approaches using achievements in life and extension and rejuvenation. There is an important issue. Accumulated experience shows that biological systems have multi-stage defense and stabilizing systems. You can't expect changing such systems using only one hit strategy. with using such a strategy, you can only slightly change that systems at most cases temporarily, which is, by the way, corresponds to the most results experiments with so-called geroprotectors. To achieve radical changes of such systems, multi-target hitting strategy should be used. As Vadim said, you can't open a door with one key, which a door with several locks with one key. The number and the type of keys should be adequate to the locks you are trying to open. There is another magic phenomenon, so-called small molecules. And it appeared that induced pluripotency can be ensured not only by transcription factors, but small molecules. There are a lot of them. At least part of them are ordinary metabolic substances and constantly exist in a cell. And in certain situations, concentrations of these metabolites could be probably enough to induce spontaneous remodeling. If we could manage to control this process, it probably could be the most magnificent decision of most of problems of lifespan extension and rejuvenation. I think this is the subject of Vadim Frankfurt. He will talk about it in more details. I just decided to mention it to show that not everything is hopeless in lifespan extension and rejuvenation. You know that there are several types, at least several types of agents, so-called accelerated aging, retarded aging, etc. Likewise, there are different types of rejuvenations depending on the targets and different targets and mechanisms. We defined around 10 different types of rejuvenation, and which need in systematization. And keeping this in mind, I and Vadim Frankfurt, Professor Vadim Frankfurt, suggest a list of rejuvenations. This list is preliminary. It will be refined, so now not to stay and discuss it in detail. Just we know that there are different types of rejuvenations, and this allows to hope that using them, especially in combination, will give some quite unexpected results. In conclusion, progress in lifespan extension and rejuvenation are as difficult as desirable. However, much has already been done. We accumulated enough knowledge and resources to start more decisive steps in this area. Especially taking into account that combination of successes in rejuvenation, multi-step, multi-target strategies, and so on, in combination with expected revolutionary discoveries in molecular biology and cellular biology, can ensure quite unexpected results in this marvelous area. However, I wouldn't like to look hopelessly optimistic, and should say that this area was quite difficult, and only future results will show what could we expect in this marvelous area of scientific activity. Thank you for your attention.
Thank you, Khachik, for your talk. I think it's actually a great introduction for the afternoon sessions. Indeed, we should all look for multi-target interventions. If there is any question for Professor Muradian, you can have 1 or 2 minutes. If not, we can move to the next lecture, which is about multi-gene target intervention in vivo.